hopefully. Cool. So, hello everyone. It's great to be here in NDC. First time NDC for me. First time Oslo as well. So it's amazing to be here. I'm, as you probably know, we're here to discuss about some web performance APIs for both monitoring and improving the performance of your app. And this is me. You can find me on the web as Whitey Combinator. Um, I'm now an engineer at Medallia doing front-end stuff. And I'm a mentor at Tech Labs. By the way, who's here doing front-end, working with front-end or cool? Yeah, just one. Yeah, quite a few as expected. Uh, so before we start, I do have a couple disclaimers. So the first one is that whenever something sounds like a lot of content or really deep, check this emoji. It means we can have further discussions after the session. The second thing is I know that 60 minutes is a lot of time, so it might get boring sometimes, but I'll try my best not to, using memes and demos. And the last thing is that I have to give it up for Zeno because the idea for this title of this talk is from his session from back 2016, where he was going through some new stuff in HTML. So yeah. So a bit of the whys behind of the session. So I'd like to go from this into, okay, let's first discuss what we already know. So we already know, for example, that we have HTTP2. It brings like multiplexing and the push API and a lot of other interesting stuff. We know we should compress JavaScript most of the time with gzip, but we also have alternatives like Broadly, and people keep building more interesting ways to do that. We also know that image CDNs are a good idea. There are even some researches, mostly by Google, where they show that you can reduce from 40 to 80% the amount of the size of your images if you serve them via CDN. Plus, it saves you a lot of work, for example, transforming images and manipulating that. We also know we should try to optimize the third-party scripts in our app. So, for example, first we can defer loading them, but we can also replace. We know that we can, for example, replace Lodash with like smaller libs, Moment.js with date FNS or other smaller alternatives. We can also update some of the libraries. So React is one example of library that each major, the bundle size gets smaller and smaller. There's the PRPL pattern out there that is, you probably heard Google speaking a lot about that. And if we have some, I don't know, really heavy work happening on the main thread, we can offload that to workers. That's one thing we can also do. We know about bundle splitting, probably. So if we have a huge bundle that's going to take a lot to download and to be parsed by the VM in the browser, we can split that into smaller chunks. And then we get to something like that. And if we do bundle split, we can also have dynamic imports and basically, for example, save users from downloading things in the browser that they might not end up using. We also, last but not least, we have list virtualization, which is something really interesting when we have like lots of content to render in the browser. So if we do that, we are, for example, sparing from doing a lot of things in the DOM, and we render only what's visible. So, but yeah, we're doing these, like, at least most of them, right? Yet, about 4 years ago, I had a similar session where I spoke about some of these items, and it was in 2018. So it's some of the things like people were already doing back then, but I constantly see myself facing some realities of the industry we work on. And to show you that, I have this map. It's basically some statistic data of people accessing our app across the globe. And in some parts of the world, like US and Europe, we have good numbers, but we have some parts of the world where we have like red or and then the good ones. So it's like I constantly face this kind of problem happening, and this brings me back to this. So that is the problem of fixing web performance, because we see a lot of things that this sounds simple. So you just go like, okay, draw the legs, draw everything. It's simple, like drawing a horse, but then you just add these tiny steps. And yeah, I'm trying to be fun. So that is the goals for this talk. So that was the first part, the why I'm here. I want to talk with you a lot about measuring using the platform we have, about optimizing using the platform. Then I'm gonna reflect about why we are all here, and then some closing thoughts. So the first part is over. Kudos. So for the next part, I would like to start with a bit of a reflection. So if I said this web app is fast, what does it mean to be fast? And I'd like to propose an exercise. So if you guys had to summarize web performance, or being fast in one metric, what would be your pick? For example, like load time, responsiveness, what else? I really want to hear from you. So if you could, I'll leave that for 45 seconds. And I want to collect the opinions of you about that. Uh, yeah, it's crazy because 45 seconds sound like a lot of time, but when you have the silence, it's like a weird silence. But yeah, I want to hear so much from you that I'm gonna be giving out stickers, or if you're the first one to answer, I got discount codes, or I can pay a pint. But yeah, another 10 seconds and we're good to go. Or maybe we could be good to go now. I think most of people can. So for this, for the next step, I have this one demo. Basically, what's happening here is I have this input field, and I'm typing things. And you can see that as I'm typing on the right, it takes a lot of time for the numbers to show up on the left. And there's a point that I got to stop typing, so otherwise my Chrome is going to crash. And then I have to wait for a given delay, and then I'm going to see the numbers. And then I have to wait again to see more numbers, and that's like really poor experience. And you could think, okay, this is like a virtual example. You are kind of on purpose blocking the main thread. But examples of that happen a lot out there. And that's why we have behaviors that are, for example, this one that is called rage clicking. So it's when we as users, we want to get so much one thing, and it's like taking some time, so we start clicking more and more. And it happens so much that we even have metrics to properly address that. So we have, for example, first input delay, or time to interactive, and others. And that's the thing. A lot of loading metrics, they don't capture the real user experience. We talk about a lot about loading, but that's only one part of the thing. And we need to think in terms of which metrics actually get what matters. So yeah, we hear a lot of people bragging on Twitter, on conferences, and etc. Like, okay, my app is loading in this amount of time. And yeah, this is a fine slide. But the thing is, load metrics are not a single number. And back to the question, I really hope this is gonna work. Yeah, live stuff is always. So yeah, those were your answers. So we have a lot of load time response. Yeah, the ones I mentioned. We also have interactive, load. Yeah, we have load a lot of things. If I were to list some metrics that we should measure, I would start first with perceived load speed, for example. That is how quickly the app can load and render all of the content. Oops, misclick. There's another thing that also has to do with load, that is load responsiveness. So okay, everything loaded, but how much it is necessary for the JavaScript on that page to run and the page can become interactive. We have then runtime responsiveness. That was, for example, the issue in the first example. So everything was loaded, but still there are some complex operation happening in there. And we also have smoothness. So it's like about the animations and the transitions in the app. Are they flowing as they should? And actually, we even have more metrics. We can, for example, measure how much of unexpected layout shifts are happening on the page in a way that the user's like, oh, I didn't expect that to happen. That's not good. And we have a lot of tools in the lab that we can use to measure that kind of thing. Lighthouse is one of them, but we have like a huge suite of options these days. But the thing is, the only way to truly know how our app or site or whatever is performing for the users is to measure that as they are using that. And I have one example from history. Has anyone had ever heard about this guy? Great. Yeah. Otherwise, it wouldn't work. So basically, this guy ran the first experiment with real users that I know in history back in a couple centuries ago. And basically, he gathered 200 monks all together, ironed then, and he ran a current, like an electric shot through them. And basically, with that, he was measuring the latency of the electricity. And he happened to discover osmosis back then, measuring latency like that. And nowadays, browsers, they do give us like a lot of APIs native in the platform that we can use to measure and to make our stuff faster. So we can go from this to stuff I didn't know, because I cannot say what you know or not. So that's the whole point of the talk, stuff I didn't know. And measuring with, let's start with measuring with the platform. To make it easier, I gathered 4 different groups for that. So we have the group that is general stuff, and those are going to be like APIs that are the basis for the other APIs we'll see. Then we have timing APIs. There's basically about figuring out how much something is taken. And then we have profiling and sensors. So starting with general stuff, we have done high-res API. That's basically the metrics for, not the metrics, basically the basis for everything we're going to see. And the performance of server, layout and stability, and page visibility. Page visibility, let's start with that because that's one of the most simple ones. So basically, this is the full code to use this API. We can either access the current state of a browser tab, or we can register an event listener. And that's really handy because there are a lot of scenarios where you can use that. We can cancel network requests, for example, if the browser tab goes idle. We can suspend like not only sockets, but any kind of communication going on. And we can pause interactive stuff like videos or carousels or any kind of heavy animation we might be doing. And there's even more stuff we can do. So we can start fetching, for example, things in the background. Let's say we did code splitting, and we have like parts of the bundle that are not necessary at this moment. We can start fetching them when the browser tab is idle, and then once the user's back, they're gonna have the full thing. We can use that to monitor, for example, if they're scrolling or navigating from one specific part of the app, and okay, apparently users are leaving when they get to this, so it's another kind of metric. And you can throttle things like set timeout or any other things that you have scheduled over time. The other one is performance observer, and this we're gonna see it a lot throughout the whole session. So it's basically a way that you can subscribe to almost any kind of performance-related event, and basically you register callbacks that are gonna be fired when the browser is idle. So that's good because it doesn't prevent it from doing any kind of work. The API is gonna be almost the same. So you instantiate this performance observer object, and you have this type. So basically, we'll have different types of entries that we can start listening to. And before we see a lot of things, let's just talk about layout and stability. That is one of the uses we have. So many websites, I don't know if that happened to you, but it has happened a lot to me. So in our websites, we have elements shifting because something loaded. So we have parts of the app. We start loading something, maybe a request or something that is async, and then once it's done, then poof, something shifts in the user. And that's not good from the UX perspective. So we can use the performance observer to spot these events. So we listen for layout shift events, and it's going to give us something like this. That is basically a lot of metadata about that one event, including, for example, if it was triggered by some input field. And the thing is, we can use that with some tools like this. This is the film strip view. And we can use that one API with that, and we can spot layout and stability. So this one example is in my personal webpage when I was fetching my avatar from somewhere else. So I had this blank space with nothing, and then the text, and then after a couple of seconds, you would see this avatar in the blank space. So that's considered bad, for example. And once we spot that kind of thing, we can do something to address it. Like, for example, add some skeleton library, like React Content Loader. So we are probably very familiarized with these from maybe Facebook, Instagram, or actually this kind of resource is common like everywhere these days. So yeah, that was the first part. The timing APIs, I split them in two parts. Um, so yeah, to make it easier and not to bore you out. So the first part is these three: user timing, element timing, and event timing. So user timing is the most generic one. Basically, we create marks first and before and after making some operation, and then we do this measure thing that is basically calculating deltas on top of our records, and then we observe for measure. And the first thing is that this plays really well with the developer tools we got in the browser. So for example, you can see the two events that we marked using this API. And we can use that with a lot of custom metrics that we can create. Like for example, to check whether the styles or the scripts on that page finished blocking, or whether the fonts were loaded. And of course, we have libraries for doing that nowadays, but under the hood, libraries are probably doing that. And to check whether some element like a hero image or some important part of the experience was displayed. And this plays really well with other tools. So for example, this is a speed curve that is an observability tool for front end. So you can register user timing entries, and you can, for example, watch how they evolve over time, like for the good or for the bad. The other thing is element timing. So as the name suggests, it's about measuring render time of stuff. And the good thing is that this one is the basis for largest contentful paint. That is one metric that we hear a lot in Lighthouse, for example. And the API is quite simple, actually. It's just this HTML attribute that you can add in some of the elements. Unfortunately, you cannot add it in all the elements. It works with images, text blocks, and like a small subset of HTML stuff. And this is the kind of response you get from the API. So again, you have a lot of metadata about how rendering for that one element happened. And again, this plays really well with other measuring tools like speed curve. That is, you can track it over time and track the key parts of the app, for example, how they are evolving over time. And not only speed curve, you can use like other tools and you get like similar results. And last but not least, we have event timing. So event timing, I love the names. So it's about the time for processing something, and it's the basis for first input delay. So it is the basis for the issue that we had in that one first example. And again, we use that with the performance observer, and we listen for first input. And here we can, for example, calculate the first input delay using some values that the API gives us. And we can use that to measure the latency of different kinds of things. For example, we can measure the latency from the moment we click on something until, for example, let's say we have a table and we have some huge operation going on when we want to reorder, maybe we want to filter. So we want to measure how this is how long it's taking. So that's one example. Or if we have a slider that is basically a way to filter data on a huge dashboard. So these are scenarios that we can use to measure that. This is my favorite part, profiling. For profiling, we have long tasks, which happens probably to be the most popular one. And we have user agent specific memory and JS self-profiling APIs. The long tasks one, as the name suggests, it is for spotting things that are taking too long, like our input in that one example. And it has this hard value of 50 milliseconds, and it's not like a magic number like the ones we use in CSS. It's more like, because it's based on this user-centric model called Rail, and it's also useful to detect when the main thread is blocked, because that means you don't have your UI is not responsive. And it's so important that it's the basis for both time to interactive and total blocking time. And by the way, these are the long tasks. We can spot them in DevTools as well. So the same things we spot in DevTools, with this API, we can spot them when they're running in our user's machine. And this is what it looks like, for example, when the main thread is blocked. So not only the input fields, but also any kind of input, or any links, anything we have, once we block the main thread with the long task, it all becomes unresponsive. To use that API, again, the observer, and then you watch for this one specific event, and then as a result, it's gonna give you like metadata about the event. For example, not only the duration, but also what triggered that one long task. Following that, we have the self-profiling API. So basically, you instantiate a new profiler. So this one is not using performance observer, and then you start doing like whatever that you think is heavy stuff, and then you can, for example, track in a service or somewhere else the stack trace you'll get for that, and it's really handy for profiling operations that you know there are gonna be like heavy stuff on the main thread, or it's also handy, for example, when you include some third-party script and you think it might be causing some performance issue, and these things are more common that we think. You can also use that, for example, debug that, and you can combine that with other metrics that we saw or that we're gonna see. Last but not least, we have the user agent specific memory. So it's a long name, and in the past we had a similar API that was the JavaScript heap API that basically we would check the memory heap in the browser. But this one is an improved version. It's more, they're not doing the same thing, but it's the best way to measure memory right now, and it works based on waiting for garbage collection to happen, and if doesn't happen, it's gonna force after 20 seconds. And that's really helpful because memory leaks, they are really, really easy to happen in the browser, even though we don't think. So, for example, when we forget to unregister some event listener, or when we don't close a worker, or when we have like sparse arrays, so, or when we accumulate a lot of objects in arrays. And there's this session by Google Chrome. It's really interesting. It's only about spotting garbage collection problems. But if I were to mention one example, would be this. So can you see where's the issue here? Or even better, is B gonna be garbage collected? Yeah, no, yeah, because that's the thing in browser, garbage collection happens not because of use, but whether it's accessible or not. And B is accessible if we do, for example, object.b. So because of that, we have this memory leak. So sometimes memory leaks are tricky in the browser, and with this API we can measure like that, and it's especially helpful, again, just like the profiling one, when you have apps that handle a lot of data in the browser. So from my experience, I can remember two scenarios. One of them was, for example, when we had a map that would plot 100,000 data points in this one box map. So this was perfect for spotting issues. And it's also helpful when you're introducing new feature, or you want to A/B test something to figure out whether you are introducing or not technical debt when it comes to memory. And when we see all of these three APIs together, like the kind of results that they gave us, we can kind of see the potential we have for better understanding what's happening in our app. Uh, the second part of timing. So now that we took a break from timing, we can talk about it again. So on the second half of timing, we have resource, navigation, and server timing. For resource timing, as the name suggests, it's better. This is the full resource cycle in the browser. And the resource timing APIs allows us to visualize that. For example, checking whether something was fulfilled via cache or not. So if we have some part of the app that we expect it to be cached in the browser so that it doesn't have to be fetched again, we can use this API to monitor whether this is happening or not. And the amount of information we can get from this API is really huge. I don't expect you to read all that. I just wanted to show that it's really a lot of information. And with navigation timing, we can also, for example, inspect the time to first byte. That again is probably some metric we've heard from Lighthouse or some other laboratory tool like that. And we can do a lot of combinations possible. Like we can check whether our service workers are working as we want them to, whether they're properly caching, or we can check some parts of the response time from our stuff. And the last one is server timing, and as the name suggests, this one is meant mostly to be used in the server. So it's based on HTTP headers that you send in this format. So you have one metric, you add the duration for this one metric and one description for that. And it's really handy to measure anything that's happening on the server in a way that can be seen on the browser. I'm going to add a screenshot in a minute. So let's say anything that might be taking some time in the server, like authenticating some requests, or running things from a template engine, or calling other services like an email service or something like that. So let's say, for example, we want to tell the browser how much it's taking for the database and the templating processing. So we would send these headers, and in the browser, once the front-ender opens developer tools, they would see this. Like, I know it's kind of short, but it shows in developer tools how much the exact values we sent. So I like to see this metric as one way that you can use to that backenders can help front-enders help them, because when you're inspecting something on the front end, you can, okay, this is the issue, and you can directly approach the backend. Okay, what's taking too long is this part of the thing in the backend, so they can straightly address that. And you have a lot of tools out there to make it smoother to adopt these APIs. So most of them comes as middlewares. So we have middlewares for Node.js servers like Express, but we have also middlewares for Java servers or PHP servers, etc. Last one, sensors. These are probably one of the most popular ones, and it's really short. We have battery and network information. So battery status, again, really simple API, promise-based. We can check information about the current status of the battery, but also how long it's gonna take for it to, for example, to run out of battery, or you can check whether it's charging or not, or discharging. And you can register event listeners, and this way you can adapt the experience when the user has got not a lot of battery, for example. Then you cannot run something that's gonna take a lot of CPU on a low-end device. On a similar way, we have network information. So again, we can check the current status, and we can register an event listener. And this is the kind of information we have. So it's going to tell first whether it's like 2, 3, or 4G connection, or even if it's a slow 2G connection. It also has this round trip time that it's really helpful. An estimation of how long it's taking for downloads, and last but not least, whether on a mobile phone, for example, the save data mode is activated. So that's really helpful, because if you're an iPhone and you activate data saver and you have a web app, you can, from the web app, identify that and, for example, not download things. And we have tons of possible use cases for that. So you can switch. One of my favorite one is switching between high and low definition for content you're serving. So for example, if the user is on 4G, you can show a video, but if it's 2G or 3G, you can show only the thumbnail, and then if they click, you play the video. And it's also helpful when you want to decide whether to preload some resources or not. So if you want to download a bundle that the user might need in the future, that might be a good thing. But if they don't have a lot of data, that might be a bad thing. So using this API, it kind of helps you making that one decision. And a lot of other decisions, you can defer things based on that. And you can even adapt to situations when they are offline. And you can even force offline mode. So for example, I've seen in video call apps when the network is so bad that they won't allow you to call at all, because they cannot kind of assume that it's gonna be like poor experience. And again, you can warn users. That's another really common thing. So if they're gonna download something, it's like, oh, you're doing that over your data. You're sure you want to proceed, and that kind of thing. And last but not least, metrics. So you can, for example, gather data about the network of your users. This is one example with React. So we're basically, based on the connection type, we are checking whether we want to render a video or a high-end, like a high-resolution image or a low-resolution image. And this concept isn't new. We have posts from back 2018 about the idea of connection-aware components. And we even have libraries, for example, this one, that they give us a lot of hooks using network information and battery status to allow us to do things in React. And this is one example, like Twitter does that. So if the user has enabled the data saver mode, they're gonna render only this low resolution preview, and then if the user clicks the image, then they're gonna see the full image, and then you're gonna download that. Woof. Yeah. Now we can talk about improving with the platform. Halfway, guys. So the first thing we have are resource hints. So basically, resource hints are work on the assumption that if we can predict some kind of behavior or some action from the user, then we can optimize based on that. And they are really simple. We're gonna see that most of them are just HTML attributes that we use, but they are effective if done the right way and based on metrics. So they look like this. Hopefully you can read. So you have like pre-connect, preload, DNS prefetch, and pre-render. And you use these attributes in links or sometimes with script tags or sometimes with images. And the first one in this list is pre-connect. So this one is really, I would say it's probably the least popular of these ones, but it does help a lot. So basically, it tells the browser to start setting up connections with the server. So this includes, for example, TLS negotiations and handshakes in TCP. And depending on your context, it helps you reduce a lot of round-trip latency. So it looks like this. If we trace this timeline, where we have first our HTML loading and then our CSS loading. Let's say we use custom fonts. Let's say we have two different fonts in our web app. So after that, we can start loading the first font, and then the second font. And only after that, we're gonna see them rendered on the browser. If we pre-connect, we can move this part to the very beginning because we can kind of tell, okay, go ahead and start connecting to Google Fonts or whatever it is where we have our fonts. The second thing is DNS prefetch. So as the name suggests, it's about domains. So it kind of warns the browser about what domains it needs to look up for. And again, it reduces the overall load time. And this one is really handy when you have resources outside of your domain. So on a CDN or on something like Google Fonts, as I mentioned, or some other domain. Prefetching is about doing stuff in the browser idle time. So it starts fetching what you need for a page in the background, but it doesn't get to render. But the thing is, it's tricky because it's about it's about working with predictions. So we got to be really sure that we are fetching stuff for a route of our app that the users are actually going to visit, because otherwise we're just spending their connections. And pre-render is just the same, but one step further. So we not only prefetch stuff, but we even render in the background. So you can be providing a really smooth experience where the person goes to a route of your app and everything is already prepared. But at the same time, you have like an even higher gamble because you're not only spending network, but you're spending their processor. The other thing are priority hints. So basically, they allow you to either increase or lower the priority for some scenario. It can be, for example, the largest. If you have something that is supposed to be your largest contentful paint, maybe an image, a hero, some key section of the app, you can increase priority for that. And you can, for example, use that to decrease priority for things that are not visible to the user in the first moment, or as we call, above the fold. And we can use that, for example, to reprioritize scripts as well. So this is how we use priority hints as an HTML attribute. So we have fetch priority, and this can be either high or low. And again, with images, or so in this one example, we are setting a high priority for the header, or it could be for the logo, anything that's key to your experience. And in the Caruso example, we are setting a lower priority for things that are only the next images, so we don't need them right now. And we can also use that with scripts. So whether we have some library being added, we can play with the priorities, and we can also do that with the fetch API. So this is like an extra configuration we can pass. So basically, we set priority either low or high. So that's really helpful for example, scheduling uh, things. And by the way, we'll speak about scheduling in a minute. Um, we also have responsive images. So basically, this is from Google, this data. Yeah, images in the desktop and the tablet, they can be like 2 to 4 times larger than the mobile ones. So if we only have this one set of images, what's going to happen is either the person on the desktop, they're going to have like not so good resolution, or the person on the tablet or any other mobile phone or any other mobile device, they're going to be downloading extra stuff that probably don't need. So with this one extra HTML attribute that's called source set, we can avoid that. So it basically looks like this, and it doesn't replace the source attribute as an extra thing. And basically, you can set, for example, different versions of the same image based on some ratio or some width ratio or some device pixel ratio. That was this. Um, the next two things are native stuff that we are used to have our own solutions. The first one is native lazy loading. So we have plenty of libraries out there for doing lazy loading. But now we have this in the browser as well. So it looks like this. Again, an attribute that you can say loading equals to lazy. And for now, you can use that with images and iframes. And basically, it works like this. So if you have something that is off the screen, uh, if you don't use that, you would be probably downloading that. If you use that, then you'll see that these contents, for example, images, are only going to be downloaded in the network tab as you scroll and as they become available in the viewport. And there are even some studies, as always by Google, on the results of that in some different companies. And they figured out that lazy loading iframes had really, really good results. So it helped reducing the first contentful paint, and it also helped reducing the first input delay. And I had some good results as well in my previous company where we started lazy loading iframes where this API was available. And the last but not least in this section, and I know I said this before, but this one is really my favorite one, is the native scheduler. So if we think about scheduling in the browser right now, we have some primitives. So we have set timeout, we have set interval, we have both request animation frame and request idle callback. And if we have workers, we also have post message, which acts as a scheduling mechanism. But the thing is, scheduling in the browser is tricky because we have to use the same scheduler. So React has a scheduler. Some apps might have a scheduler. For example, Google Maps, they have their own scheduler. And having more than one scheduler probably leads to resource fighting amongst these different schedulers. And this happens because we don't have proper scheduling primitives. And last but not least, we still have to think about the browser work. We still have to think about rendering, garbage collection, etc. So this is kind of realization in the front-end world these days that we need better scheduling primitives. And people are aware of that. That's why we have this API that's on the way. And basically, this native scheduler is supposed to be a more robust solution that is directly integrated into the event loop. And most of the things are promise-based, and it allows you to control and schedule things in a more flexible, but at the same time united way, so that you don't have each framework or each app sometimes implementing their own scheduling solutions around the very few primitives we get. And the good thing is also this is really, really well aligned with the work that the React core team has been doing. They are even part of the discussions. and not only React, but Polymer teams, some teams at Google and Chrome, and the whole web standards community. They're all working together on that. There's a really good talk, by the way, about this whole topic and doing both on and off main thread loading. This one APIs, this new API is kind of an umbrella of APIs. So my favorite ones are these four: post task, uid, wait, and is input pending. Let's explore some of them. So post task, as the name suggests, it allows you to schedule something to be executed, and it's promise based, but it's really configurable. So you can, for example, define different priorities. It can be user blocking, or it can be something that doesn't have like really good, not high priority. We can also define delays for some tasks we post. And it gets really, really nice when we start, for example, working with task controllers, because then we have signals, and we can check the status of signals, and we can also use them to change the priority of something from background tasks to blocking or vice versa, and we can even abort some signal. So that's really great scheduling that nowadays we would only get if we use the library or something like the React scheduler. And Airbnb, for example, they are already using some parts of the APIs, the ones that are usable, for improving their experience. The second one is input pending. So it's part of the navigator, that's scheduling, and you can basically use that to stop doing something if you have to handle input. So it would be like a fit for the problem we had in the beginning. And the nice thing is that you can even filter what kind of inputs we wanna listen to. So we can, for example, just say, okay, I'm interested in mouse or in key down advance. And this one is a work mostly of Facebook. And again, they're using, and this is like another signal that it's really, really aligned with the React team. And the last one for this API is the uid one, and most of this API is probably the most abstract at this point, out of this umbrella, and most of the examples are just like it's a promise-based thing that basically allows you to uid execution back to the browser, and we can combine that, of course, with is input pending, for example, to resume doing something if there's no input pending. But I think that this library is called main thread scheduling. It's not a polyfill, but it's basically heavily inspired by the spec. And if we check this library documentation, we have like better examples. For example, this one, where we are going through a lot of files and all the lines in this lots of files to perform some search operation. And if we get the uding thing in our mind, we can go back to the example we had before, of the input problem and etc. And we can think, how could we improve that? So this is the source code for that one problem. And this resourceful operation, I'm kind of mimicking something that's really heavy. It could be, for example, some data filtering or something like that. We could turn that code a bit and, for example, promote it to a generator. And inside this generator, we yield execution back to the browser. So if we see that, these are going to be the results. So as you can see, this API is compatible with suspense, if you're familiar with React suspense. And you can see that at no moment I cannot input. Like, it's really smooth. And of course, I'm going to see sometimes that it's performing some CPU-bound operation, but the UI is smooth all the time. And this is the full code for that one. I don't expect you to read. I just wanted more to show that it fits in 40 lines. So that's the key thing of yielding back to the browser. And I was like this when I figured out about these things. But there's much more. So there are things we can do, like with CSS. For example, we have font display swap to avoid fonts having to wait until they're rendered. We have wheel change to optimize animations and transitions. We can import something once it's visible, like a component, using intersection observer. We have also send beacon for which is another scheduling primitives. We can combine canvas and workers with using off-screen canvas. So that's a really good way of offloading canvas stuff outside of the main thread. And there are things on the server as well. So we have this thing called HSTS, and basically it allows you to skip the round trip latency that you would have from going to HTTP to HTTPS every time. Every time the user types HTTP and you want to send them to the HTTPS thing. So there's one example. And you can avoid even more extra round trips with the quick protocol part of the HTTP free umbrella. But um, even though a lot of these things are interesting and etc., I love this session by Kites that's called "You're Not Facebook." So, most of us are not building schedulers or performance monitoring tools on a daily basis. So yeah, you can use observability services like Calibre or SpeedCurve or others. We have libraries like Core Web Vitals by Google that, for example, it comes out of the box in Create React App and some other applications. And even some platforms like Versal, they have their own analytics solutions. So yes, I would say that most of the times observability services that have SDKs built on top of the APIs we saw, they're gonna serve our purposes, but we can enhance them with libraries like Web Vitals, or we can create our own abstractions on top of these, uh, and framework-specific abstraction like custom React hooks. And this is kind of related to the next part, that is move fast and break nothing. So yeah, you got the reference. Um, so for example, some of these APIs, we're gonna see that they're available in only a subset of browsers. So they're not available in Firefox and Safari, for example. Some of them are available everywhere. And you might be wondering, okay, how can I use them if I have users from different browsers? Um, I don't think it's a yes or no question, but one solution I came up with when I needed to was this library. It's like alpha, so don't use it, but just get the abstraction. And it's basically a library for doing pattern matching in React. And basically, let's say we have this app. It's supposed to render videos from previous NDC Oslo editions. And this is the full code for the app. We have suspense wrapping that, and you will see that I'm using this with components and the match components. This is the key part. And why suspense? Because I'm lazy loading these components. So I'm lazy loading video and the preview components. I'm using the library from Google I showed, like that is use network status. And then I have these three components: with, switch, and otherwise. And I'm pattern matching on top of the network info. So the other important part is the suspense part, because this is the key for having the conditional imports. And then I use with against the different possible cases. So it can be 2G, it can be not supported. The API might be not supported in the browser, like Safari, or it can be 3G, 4G, etc. So, for example, Safari users where this API is not available, they would see that. So they would see that the API is not available, and because it's not available, I'm not taking the risk, I'm rendering the video. But if you are in Chrome, and this is the example, yes. If you are in Chrome, and you have like a good network in the API, you're gonna see this. So it's a 4G connection, I could detect it, and I'm rendering the video. But if you are in Chrome, and here I'm gonna simulate like low end mobile with like bad internet connection, what you're gonna see is just a preview of the video. And the other interesting thing is in these scenarios where I have, you will see that in each scenario, I'm downloading only the bundle. So here I'm downloading only the preview, and here I'm downloading only the video. So no extra chunk of code is downloaded. That's not necessary. So going back to why we're here, basically we build all these tools to run in browsers. And it's quite common that we not usually care a lot about which browsers are visiting our app. I myself sometimes forget to do this exercise, but whenever I do, it's always interesting. So for example, this is some monitoring data from the last 3 months about which apps, which browsers we're using. So of course we're gonna see Chrome, we're gonna see Safari, Edge, and all of these mainstream browsers. There's gonna be Explorer in there as well. But the cool thing is when you start exploring more, especially if you have like a lot of visitors. So you get to see things like this. And the more you scroll, the darker it gets. So you're gonna see, for example, Blackberries, you're gonna see Nokia, and you're gonna see even PlayStations accessing the app. So yeah, we have a lot of browsers out there, and you know what else? What are browsers? These. So in-app browsers like LinkedIn, Instagram, Facebook, they are all browsers, and not only they are browsers, but sometimes they have like huge shares depending on the market you're targeting. And these browsers, they run on different devices and different connections. And for me, that was one kind of reality check when I saw that research that basically is the first input delay was 7 times worse on for mobile users. So it's easy to visualize when you see a chart. So check out how much more yellow and red zones we have for mobile users. And not only that, but it's usually easy that we forget about bandwidth of our users. So we still have some parts of the globe that are where the vast majority are either 2 or 3G connections. And we can see that reflected, for example, across the kinds of connections accessing Twitter and the kinds of connection accessing Jumia. This is like one of the big e-commerce in Nigeria. And not only that, but the global 4G picture is like that. So having 4G doesn't mean a constant connection speed. So this is how much it can vary from a country to another, all LTE. And these connections, devices, and browsers, they are used by people. And research shows that basically how long it takes to load the app or performance in general for people is the top one priority, even more than, for example, whether it's easy to use or if they could if they could perform the activity they meant to. And I love like some researches in this area because they're really funny. So the first one is from back in 2009 when they figured out that 40% of people in the UK, they become physically violent towards their computers. Years later, they did a similar thing in the US, and it was again 33% of Americans, they had either yelled or screamed or even physically assaulted the computers. And then in the same year, there's this another really interesting research that is basically showing how this impacted the conversion rate or the engagement in the app just because of frustration. And fast forward time, I love this one because it's basically how much the delay in a web page. So they basically mimicked a delay. They virtually delayed the thing, and they had ECG devices attached to the people. And basically, this is the effect of that in their heart rates. And then people from maths, from like doctors, they figure out that this is kind of like watching a horror movie alone. And of course, this reflects in the behavior in the browser. So yeah, more than half of the people are going to abandon your app or your site if it takes more than 3 seconds to load. And it's crazy to think that even it changes from one part of the globe to another. So people from different parts of the world, they're going to have like a different threshold or a different limit of frustration. And there's studies around that that show, for example, that being mad with an app in the US is different than in Germany, that is different in Australia and Canada. So this is how important it is to actually think about how our users are feeling, because this directly impacts business. And it's crazy to think that like we know that long tasks, they do affect the time to interactive, for example, but it's crazy to see how much this changes your conversion rate. And it's crazy to see how much it's also worse in the mobile. So in mobile, they take up to 12 times longer, like long tasks 12 times longer. And actually, half of the load time could be spent just running in long tasks. And it sounds terrible when you say like that, but when you visualize the conversion rate on a chart decreasing because of that, then it's even worse. So back to why we're here. Basically, people use way more different browsers than we tend to think, of course, depending on your audience. And 5G and 4G is not the same across the globe, and sometimes it's really limiting. And yeah, being having 4G and being in or 5G and how fast it is changes from one part to another of the globe. And yeah, anything that slows down or prevents them, the users from accomplishing, yeah, this is an obvious one, prevents them from accomplishing this goal is going to cause frustration. And people are going to quit apps or sites because of frustration. So, some closing notes. Oof. On top of that, the first one is always try to associate like business metrics and performance metrics, because we see more and more, especially on social networks or some solutions or some libraries, they gaming metrics just for the sake of that showing they're fast. But if you do correlate business metrics, there's no way to game these metrics, because that's actual behavior from the users. That's like your conversion rate. That's the actual impact. And it's usually a bad idea to assume that people are gonna have like not only fast connections but also fast devices. It's crazy to see the amount of low-end devices people have, and that's why it's important to test on real networks and on real phones, real devices, and to collect field metrics. Uh, I know a lot of these APIs are exciting, and we could start using them like tomorrow. But it's also important to avoid the observer effect. So it's like when you're, for example, watching some really beautiful animal and you scare it because you're watching it. So try some of these APIs. They might be heavy or they might impact the performance of your app. So it's important that you don't change the performance of your app because you're trying to track the performance of your app. It's also important that you get rid of the noise in the metrics. Is mostly in huge scale apps, we're gonna have like bots, and we're gonna have like lots of things that are generating numbers, and that might be confusing to our reports and to understand the full picture of our app. There's no silver bullet. None of the solutions I presented, for example, are gonna work in 100% of scenarios, and none of the metrics I presented are gonna be relevant in 100% of the scenarios. So it's important that you identify the core metrics for your business, for your app. And I know it's a cliche, but yeah. One of the things I like is this quote by Edward Deming. So in God we trust, others must bring data. So yeah, just trust data. Don't trust me. 8 years ago, I was saying that Angular would be the future, for example. And nowadays, I talk about React. Um, it's not a direct conclusion, but it's a closing thought, though. We're hiring in Medallia in a lot of parts of the globe. So if you want to do interesting stuff, if you want to work in performance squads, reach out. These slides for this one session are going to be available in my speaker deck profile. So yeah, you can scan it. All the links are going to be there. If you like that kind of topic as well, I have other sessions about performance and about internals of web APIs and internals of React mostly. If you want more information about Medallia, or if you want to see other sessions, this one sessions, everything, this is the go-to link. As I announced, I do have stickers. So if you're that kind of person like me, you can just reach out. Let's have a chat about performance or whatever, and then get some stickers. And that's all I had. I don't think we have time for questions. If we do, you can have questions. If we don't, I'm going to be around. Let's chat. Thank you.